Where are all these fish going to come from, you might ask? Right? Okay, where are they coming from? Okay, this is what most people think of when they think of fishing. And where am I going to get the fish to eat for dinner tonight? And they think of a guy, standing here with his fly rod or whatever in this huge lake, you know. Well, yeah, okay, but here's a key distinction between what people perceive in terms of where their seafood's coming from versus reality. The density of fish in such a lake like this. We live next to a lake that's in the Finger Lakes region. The lake I live next to, Cornell University, it's 60 miles long, 3 or 4 miles wide, and 500 or 600 feet deep. And how long does it take to catch a fish out there? Well, to catch one legally sized trout takes like 45 hours of fishing. Can you believe that? In other words, it takes forever because there aren't hardly any fish out there. And the reason is because if there were more fish out there, they would all die. Yeah, they would all die because of disease issues. So the natural environment is full of vectors which will contribute to fish disease. You just can't do it. So they're not very dense. But aquaculture, it looks like this. Okay? And look, there's pretty high densities. Here's underwater sea cages. These represent raceways. These are intensive ponds. This is rope culture. Anyway, very, very dense. Okay. Another shot here. Here's raceways where the water comes in at one end. These are concrete walls that divide each raceway. Water comes in at the top. You can see the water coming in here, goes down through. There's a fairly rapid exchange of water to maintain the water quality environment necessary to support the fish. Another shot of an indoor raceway. Okay, the thing to remember here is that we have a term called hydraulic retention time, and that's okay. If this raceway was totally empty, and I started filling it with water, how long would it take to fill it up? So if it was all empty and I filled it up in 35 minutes, we say that has a hydraulic retention time of 35 minutes. Okay, so it's what we call turning over every 35 minutes. Raceways typically have HRTs of about 15 minutes, so they turn over very rapidly. And so you can imagine if I'm turning over this raceway every 15 minutes, that takes huge, I say huge quantities of water. Okay. The other most common thing we see around the world are ponds for aquaculture. Here's some bunch of catfish ponds. These things, they're typically rectangles. They're going to be 2, 3, 5 hectares in size. But a very interesting thing here is you notice how the ponds are all different colors? Well, that's because they all have different water environments. So this is not a repeatable or a duplicate set of raceways, ponds, because the environments are all different in each one of them. So how are you going to reproduce fish on a repetitive basis? Ponds have a lot of challenges. They also use quite a bit of water just because of evaporation. So that's what I call also a mature technology. Okay, and at least in the United States, the ability to produce fish on a cost competitive basis with worldwide produced fish, it's a constraint right now. It's difficult to do that. A lot of our ponds in the South, Alabama, Mississippi, are being converted actually back into dry land production. So it's kind of ironic. It went from cotton production in the 40s and 50s and to catfish production in the 60s, 70s for 40, 50 years. And now about a third of all that acreage has been repurposed back into land, dry land culture, soybeans typically. Okay. And here's some more of these intensive. This is net pens. So primarily aquaculture is from these two sources, either raceways, ponds, or net pens. Net pens have some bad publicity. A lot of bad things are said about them, most of them not being true, such as they attract sea lice, and then when migrating salmon swim by, the sea lice go out and attack the migrating salmon. Yeah, that's kind of absurd. Also, the net pens produce a lot of waste material, which they do. It collects on the bottom of the ocean floor, and then is a large pollution source and degradation of water quality. That could be true in the case where the net pens are not sited properly. But the key thing on net pen production is that they are sited where the tidal exchange of water is large. So the 24-hour cycle twice a day is that you might get 5 to 10 meter changes in elevation in the ocean level, and so that causes a large amount of flushing that occurs. Okay. So net pens are they're also a mature technology. Almost all of 2/3, I think, of our salmon come from net pen production. Most of the salmon comes from 3 areas: Chile, eastern and western Canada, and Norway, primarily. Okay, and it's pretty well equally spread among those 3 locations. Then we have recirculating aquaculture systems, and the acronym is what? RAS. Okay, so here's some examples of indoor, and quite nicely done, I would say. This actually is a big sturgeon farm. This is actually a raceway configuration. Here are round tanks. Here are outdoor tanks. I think this is actually a project that we did in Haiti. This is a RAS system. Okay.